Okay, you guys, so example 5 and 6 are very similar to example 3 and 4, but if you notice, we now have fractions, which fractions are our friends. We love fractions. Okay, but we're going to be incorporating a rule in order to solve with the fractions. Okay, so something we need to go over before we do this. Okay, if we see a fraction, so let's start on this side. If we see a fraction, okay, if you ever want to move a number either from the denominator to the numerator or the numerator to the denominator, all you have to do is change the sign of your exponent. So if you look on this side, we have 1 divided by a to the positive first power. That is equivalent to, if we move a to the first to the top of the fraction and change the sign to a negative, those are equivalent statements. So if you see here, this is over 1. So all I did was I moved a to the first from my denominator to the numerator, and bam, my exponent, my 1, became a negative 1. That's it. Okay, the reverse is true as well. Okay, so if I start, let's go on this side now. If I start with something in the numerator and I want to move it to the denominator, so I want to move it down. Okay, all I have to do to move it from the numerator to the denominator is change the sign of my exponent. So since my exponent is a negative 1, to move it to the denominator, it turns into a positive 1. So either way is correct. So moving from one side to the other, you just change the sign. This a to the positive 1, we move to the top, change the a to the negative 1. My a to the negative 1, we move it to the bottom, turn to a to the positive 1. Okay, so we're going to be incorporating that trick into this problem. Okay, so same as last time. Remember when we set up these awesome problems, first we start by setting it equal to some sort of variable. Okay, which I've been using x. You can use whatever you want. Okay, and the next step, we got to convert these bad boys into an exponential to evaluate. Okay, so the base of our exponential is the base of the log, which that's this little guy chilling out with my log. So the base of my exponential is now a fraction. It's going to be 1/2. Okay, which when you have a fraction, it helps to put it inside a parenthesis so you know everything applies to that parenthesis. Okay, so I'm going to have 1/2. So we can zoom in a little bit. There we go. Alright, I'm going to have 1/2. And then remember, these two trade places. So my x is going to hop to be the exponent of my 1/2. Have my equal sign, and my 8 is going to hop to the other side of my equal sign. Alright, so last time we said, okay, we need to find a number that goes into each base on both sides. But you're probably like, Miss Long, what are you talking about? We have a 1/2 now. Nothing really divides evenly into a 1/2 and 8 other than 1. Okay, so this is when fractions kind of cause us problems. Okay, if you see a fraction with an exponential and you're trying to solve, it's helpful if you can change it into something that's not a fraction. So I'm going to kind of be looking at this rule right here. Okay, currently that 2, if we look at the 2 and 8 do have something in common. Sorry, I kind of blocked the 8. Okay, the 2, if I block that 1 on top, okay, 2 and the 8, sorry, still blocking it. But anyways, 2 and the 8 have something that are in common. 2 does go into 2 and 8. So if this was a 2 instead of a 1/2, I could maybe work through the problem. Okay, so I'm going to make that 2, this is secretly 2 to the first right here. I'm going to move that 2 to the first to the top, so it will not be a fraction anymore. That way I can possibly get the same base on both sides. So the way we move something to the top of a fraction, we just change the sign of the exponent. So since this is a positive 1 down here, when we move it to the top, it'll change to a negative 1. So this is the same as 2 to the negative 1. Okay, so secretly this is over a 1, okay, because I moved it from the denominator. There's still a 1 there, but I'm not going to write it in the problem because it'll kind of make it look a little more confusing. Okay, so now the goal is to get the same base on both sides. Okay, so I have a 2 here. 2 goes into 2 and 8. Okay, so we want to try to get a 2 on both sides. So I'm going to write a 2 on both sides. because that's something that goes into 2 and 8. Okay, now we're going to be simplifying on this side. If you ever have two exponents that are side by side like this, what you do with them to combine them is to multiply them. Okay, whenever you have two exponents side by side, you multiply those bad boys together. Okay, so negative 1 times x is 2 to the negative 1, x. Okay, negative 1 times x is negative 1x. So that's 2 to the negative 1x power, which I know is a little weird, okay, but we're going to get through it. Alright, and then on this side, we want to know 2 to what power will give me an 8. So let's see here. 2 times 2 is 4 times 2 is 8. So that would be 2 to the third power. Alright guys, we have accomplished our goal. We have gotten the same base on both sides. Holy hot dog. So now that we have the same base on both sides, we can just set those exponents equal to each other. So I'm going to set negative 1x equal to 3. Okay, which last time we were done at this step. Okay, last time we already had an x by itself. If you look up here, x was already by itself. Okay, but this time x isn't by itself. So guess what? We got to solve for x. Okay, and then we'll be done. Okay, so let's look here. Okay, to move this negative 1 is getting in our way. The way that we move negative 1 to the other side, it's secretly multiplying to that x. So the way we move it is by dividing by negative 1. Okay, so I'm going to write my answer up here. Okay, so negative 1 divided by negative 1 cancels out and turns to positive 1. So we have a positive 1x, or just an x, equals 3 divided by negative 1 is negative 3. So x is negative 3, okay? Or you can write like we've been doing, log base 1/2 of 8 secretly is just negative 3. That's all it is. That long thing right there just equals negative 3. Ta-da! That's it. Alright, now example 6 is very similar to this one. Alright, so if you think that you understand example 5, go ahead and pause the video and fast forward to the end and see if you get it right. Alright, so like last time, before we start solving these problems, we always set these problems equal to an x, so we can have something to work with. Alright, next step, we got to convert that bad boy into an exponential. So, the base of our exponential is the base of our log, which the base of the log is secretly a 7. So that will be the base of my exponential. Okay, and then remember, these two are going to trade sides. So the x is going to hop to be with the 7. Alright, and the 1 over 49 will hop to the other side. Okay, so currently we have this fraction which is causing problems. Okay, and if you notice, okay, if that 49 was moved to my numerator, okay, something does go into 7 and 49. Okay, I can work with that, but I can't work with 1 over 49. Okay, so we're going to be using this rule over here. Okay, this is like 49 to the first power. And the way that we move it up is just by changing that to a negative. The way we move it to the numerator. So we move that bad boy up. We just change the exponent to a negative since it started off as a positive. If this would have been a negative number when we moved it to the numerator, it would have turned positive. So all that happens is your sign changes. So I have 7 to the x equals 49. To the first power. Sorry, negative first. Alright, so all that happened was my positive exponent, when I moved it up, turned to a negative. Alright, so now the goal is to get the same base on both sides. Okay, so let's think about it. What's something that goes into 7 and 49? Okay, well, the only number other than 1 that goes into 7 and 49 is 7. Okay, so my goal is to try to get 7 on both sides. Alright, now, the reason why I wrote it like this. Okay, I'm trying to change this number right here, and only this number. Okay, the negative 1 we'll deal with in a little bit, and since negative 1 is in the exponent, it's going to stay in my exponent. All we're changing is 49. Okay, so let's think about it. 7 to what power will give me 49? Well, 7 times 7 is 49. Okay, so this will be 7 to the second power. Okay, Okay, so be careful. All I did, I just changed my 49 into 7 squared. Those are the same number. And I still have my -1. That didn't go away. Okay, now before we can set those exponents equal to each other, so I'm going to rewrite this as 7 to the x, we have to do something about these exponents. Okay, which if you remember from this side when we solved, whenever you have two exponents side by side, an exponent right beside an exponent, all you got to do is multiply those bad boys together. So 2 times -1 is -2. So this is 7 to the -2. Alright, and now that our bases are the same, we got 7 and 7, okay, we can set those exponents equal to each other. So this one's actually a lot easier, because when I set my exponents equal to each other, x is already solved for. It's already by itself. Nothing is in the way. Okay, it's just x. This side we had a -1 in the way, so we had to deal with it. Okay, so this one is donezo. So x is -2, or you could rewrite the problem. So log base 7 of 1/49 is secretly just a -2. That's all that log value equals. Bam, that one is done. Alright, let me zoom out so you guys can see that. Alright, so again, log base 7 of 1/49 equals -2. Alright guys, it's been a blast.